short addendum to the process we went through for partial fractions on this particular expression, okay? And we got everything down to x equals this multiple of x cubed, this multiple of x squared, this multiple of x, and this number. This gives us 4 equations, system of 4 equations. These equations are fairly easy to solve. We get into some, inconvenient fractions. The worst one probably being A or C, but these are not particularly difficult fractions. The process of finding common denominators and stuff is a little involved, but it's worth seeing this. So we have these 4 equations. We notice that we have a d, a negative 2d, a d, and a negative 12d. 2 of the equations just have plain old d. This makes d very easy to eliminate. We also notice that we don't have a b in the first equation, so we choose to add multiples of the first, or add the first equation to multiples of the other 3. So if we take the first 2 equations, we see we have to add negative 2 times the first equation, and I said that wrong. We add multiples of the first equation to each of the other 3. When we do that, we're going to get down to a system of 3 equations. Here it is. And then when we have the system of 3 equations, it turns out that b is going to be easy to eliminate because we have a b and a negative b and a negative 6b. Adding multiples of the first equation to each of the other 2, we get down to a system of equations in 2 unknowns. That system is again easy to solve. A is easy to eliminate. C would also be pretty easy to eliminate, but A is a little easier. We add 3 times the first equation to the second. A is eliminated. We get C. So having the value of C, it's a fraction, that's a little inconvenient. We plug it into the first equation. We come down here and we solve for the remaining variable A. We get A, and then we take the A and C values that we have here and here, plug into any one of these equations. Well, the first equation is probably the simplest, so we plug these values into the first equation, get this equation which we solve for B. Now we have values of A and B and C, and we plug those into the first equation. We actually only need the values of A and C since there's no B, and we then easily solve for D. I didn't go through the details of solving for D, but I believe it's fairly straightforward. Now, good chance that I made an error in some of the arithmetic, but the process should be clear. Just in a little more detail now. To eliminate D from the first 2 equations, we're going to add negative 2 times the first equation. Sorry, we're going to add 2 times the first equation to the second. That'll give us a 2D matching the negative 2D. Here we have it. And we add these up to get A plus B plus 5C equals 0. And we write that over here as the first equation in this system. Then we eliminate D again from the first and third equation, and we simply subtract equation 1 from equation 3. Okay, so we do equation 3 and add the negative of equation 1. Here we have it, and the D's go away. We get a 5C here. We get our negative B because there's no B to be involved here. And we get negative 7A. There's our equation. We write it down. And then we do the same thing here. We do the fourth equation plus 12 times the first. That'll give us a 12D to match the negative 12D. And we get this equation, which we write down here. Okay, well, that's actually very simple. I don't guarantee I did all the arithmetic correctly, so you might want to check it out. Then we choose to eliminate B in these equations. We add equation 1 to equation 2, which is going to eliminate B. And we get this. I didn't write out all the details. And then we add 6 times the first equation to the third. That'll give us a 6b to match the negative 6b. And we get this equation. And then, as I said before, we add 3 times the first equation here to the second. We get a simple equation for C. We take that value, plug it in. We get this equation, which we solve for A. We plug this value for C and this value for A into this equation. So there's the A and there's the C. They go in here, and out comes this equation. We solve it for B. And solving this equation for B, we did go to a little bit of detail in finding a common denominator for 48 and 80. We could multiply the whole thing by 48 times 80, but the numbers would get big, so we chose to find a least common denominator. 48, we did a prime factorization. We got 2 times 2 times 2 times 2 times 3. 80, this denominator, 2 times 2 times 2 times 2 times 5. Our least common denominator then has to have factors that essentially cover each of these factorizations. Meaning, if we've got 4 2's, we're good. But then we need a 3 to cover this equation, and we need a 5 to cover this equation. And our least common denominator is then this product, which is 240. So we multiply everything by 240 to clear the denominators. Okay, well, that's fairly easy. 48 and 240 is 5 times negative 5 gives us negative 25. We got our 240b. 80 goes into 240 3 times. Multiply that by 15, we get 45. And there we have it. And we get 240b equals 20. B is 20 over 240, which reduces to 1/12, which is a fairly simple fraction. So now we've got our values of A, B, and C. We don't need the value of B in the first equation. The values of A and C suffice. And boy, I did make a mistake here. So let's go ahead and correct it. I have 5 over 48 for A, but A is negative 5 over 48. And we add that to 3 times C. Well, that's going to give us negative 15 plus 9, which I believe is negative 6 over 540. I'll do that again in my head. 240 is a common denominator, so multiply by 240. We get negative 25 over 240. And we get 9 over 240. I said negative 15, so I already made a mistake. And negative 25 and 9 is negative 16. So that my negative 34 over 240 should be negative 16 over 240. And that reduces to negative 1 over 15. Okay, so this should be, it's going to be a little messy. Negative 1 over 15. If I divided that correctly, I'm pretty sure I did. Okay, so little modification, but I didn't really have room to write down all the factors, but I'll do that now. So we get A equals negative 5 over 48. B equals, let's make sure I've got it, 1/12. C equals 3 over 80. And D equals negative 1 over 15. That's what I've just got. Now, if we want to write this expression as in this form, we now have our values of A, B, C, and D, and we can do that. Now, I think I've said, but I'll say it again, because I'm not sure I said it on the video that I apparently lost. Apparently Zoom didn't get it for one reason or another. I would not ordinarily, I certainly wouldn't put anything this long on the final exam. I might ask you to show me what the form of this thing is, okay? Show me your starting point. But I probably wouldn't ask you to do all of this and then all of this. You can expect, in other words, if you have to actually do the solution, you can expect somewhat simpler problems.